I've got a collision here between two blocks. So before the collision, this is going along, it hits this one goes back and one goes forward after the collision. After the collision, the momentum of the 2.4 kg block is greater than the momentum of the 1.2 kg block had before the collision. Explain why this is the case using the principle of conservation of momentum. So I'm going to call this block A and block B. This is before, so we'll call it initial, and this is the after, so we'll call it final. Alright, so let's, using the principle of momentum, work this one out. So the momentum of everything initial, momentum is equal to mv, mass times velocity, and there's two things, block A and block B, so it's the mass of A times the initial speed, and use the initial speed of A, plus the mass of block B times the initial speed of block B. But the initial speed of block B is 0, so it equals the mass of block A times the initial speed of block A. That's the momentum up before. After the collision, the momentum is the same. Momentum is conserved. Okay, so the final momentum equals initial momentum, which equals ma times ua. And we know the mass, I should have put this in, it's a 1.2 kg block, so it's 1.2 times ua, which equals 1.2 times ua. Right, that's point 1. After the collision, we also know we can actually write out the final momentum. So we know this 1.2 ua equals the final momentum, which equals this momentum plus this momentum, which equals mass of A times the final speed of A. And what do we notice about that? It's going the other way, so it's negative. Plus mass of B times the final speed of B. So let's put all the numbers in. We get 1.2 ua equals negative 1.2 VA plus 2.4 VB. Now, what are we comparing in this question? We're comparing the momentum, we're showing the momentum of the 2.4 kg block after compared to the 1.2 kg block before. So the momentum of the just this one after is equal to this guy here. Here he is, that's the momentum after. MB times that, and we can rearrange that to find a number for that. So let's rearrange it, put this on that side, we get 1.2 UA plus 1.2 VA equals 2.4 VB, which equals the momentum of B after collision. And now we've just got to finish it off and tidy it up. So it certainly is a bit of a difficult question, but let's show why this is the case. So momentum of B final is greater than momentum of A initial, because here's momentum of B final, which is equal to 1.2 UA plus 1.2 VA is greater than, and what's the momentum of A initial? The initial momentum of A is this 1.2 times its initial speed is greater than 1.2 UA. This was a very, very tough question, and was probably, I find it easier to explain using algebra like this. So go through this a couple of times, practice this one a couple of times, before you really get it yourself and can really understand and can write this down clearly.